Hello, so tonight I want to finish the chapter 7. Chapter 7 of Python for data analysis. Yes, and then what I will do for next part is, tomorrow I will start to look at the chapter 8 and chapter 9, chapter 8 and 9 and chapter 10 in the morning. So in the morning, I will finish 3 chapters, and I think it will take me like 4 hours. So yeah, I will do it tomorrow morning, which is 27th, and December 27th. And also tomorrow in the afternoon, I will start to work on these 2 books. So I will just think stats and think Python. And I will finish these 2 books exercise first because after every chapter there will be like exercise, and I will finish them first and then to check if I miss something, because I already have some like statistics and Python knowledge. So I just wanted to do the exercise and to think about to I mean to think a lot before you start to just read something. I think it's a better way to help me to study. Yeah, to like study efficiently. So yeah, so let's go next part of, I mean, the part 2 of chapter 7, and I will share my screen with you first. So we are looking at binning. Yeah. So first what we have is actually, if we want to apply bin to some series, first we need to have the series right age. Second, we need to have bins. So then we use pd.cut. See, so right now we have already created this function. We use this cut and to divide the series into bins. Then the next part for us is so this categories, this CATS object. So it's a special categorical object. The output we see describes the bins computed by pandas cut, and then we can treat it like an array of strings indicating the bin name. And then it contains a categories array specifying the distinct category names along with a labeling for the age data in codes attributes, right? And so for example, okay, 20 falls in this range and 22 falls in this range. So what should we, so what's in this, okay, what's in this CAS code? What's in there? Okay. So it means that they are in the same 0, 0, 0. It means that they are in the same range. And let's see what is categories. Okay, this is the category. So there are 1, 2, 3, 4, 4 of them here, right? 1, 2, 3, 4. When you have 5 numbers, actually, you only have 4 ranges, right? So then we look at, okay, value counts. How many of these ages fall into each period or each range. So that's what we can get. And then the next thing we want to look at is, so consistent with the mathematical notation for intervals, parentheses means that the side is open, while the square bracket means it is closed, means it is inclusive. So we can change which side is closed by passing right is equal to false or left is equal to false. So here is a way to create a different cards. So right is equal to false, see? And then we can also assign group name like this. So right now, after this one, we have group name. And so let's check. Okay, we have another, data. What's this? This must be some like, okay, it's a series, it's an array, and then what do we do here is to, we compute equal length bins based on the minimum and maximum values in the data. So we want to uniformly distribute the data chopped into 4 parts. So that's what we are doing. For precision is equal to 2. And so this is our, okay, range. So if we don't know how to divide, how to create bins, we can do this, which is easy. And the next thing we will look at is, okay, we can do quantiles, which brings the data based on sample quantiles. Depending on the distribution of the data using CART will not usually result in each bin have the same number of data points, but use QCut uses sample quantile instead. So we can obtain roughly equal size bins. Right, and similar to CART, we can pass our own quantiles. Actually, I use quantiles to to create the range of company sales, which I think is very interesting because, yeah, sometimes actually is the your manager or a salesperson or other people that help you to identify which range you need to set. For example, for some customer, so how to like define big customer, medium customer, and small customer, right? Based on their sales. So for example, like the yearly sales of this customer is like 10,000, then or 100,000, then we can say that, okay, you are a big customer, but it will change. So actually in the real world, that how to identify this depends on, sometimes depends on how you discuss with the other people that who use your data, because they have some idea that how I will treat my customers and based on their sales. So it depends, but you need to know how to do this bin things, right? And then the next part we are looking at is detecting and filtering outliers. So filtering or transforming outliers is a largely matter of applying array operations. So we consider a data frame with some normally distributed data. Let's see this one, which is, let's create a data frame like this. So what's in there? Okay, this data frame, okay, there are 1,000 rows and 4 columns. And let's check this graph. Suppose we want to find the values in one of the columns exceeding 3 in absolute value. So what we are doing, okay, just like before. So we find it, which is bigger than 3, and just like all rows have a value exceeding 3 or minus 3, we can use any method on the Boolean data frame. Okay, it's over 3 or less than 3, exceeding 3 or minus 3, then values can be set based on these criteria. Here's code. So the following code is to cap values outside the internal interval -3 to 3. Okay. So this is a way, but outlier actually is a very important topic. That how can you identify outlier? So for example, yeah, for a series of of value of integer or float numeric values, and you want to exclude some outliers, for example, which is like over which is larger than 3 multiple your IQR, which I mean, there are many ways for you to identify outliers. So, and this is a very important question because for many interviews, they will ask you this question. I will have been asked that, okay, how do you deal with the outlier and okay, what method will you use to remove outlier? First, how to identify, then how to remove that. Then what do you think outlier is meaningless? And also some algorithms, some machine learning algorithms are sensitive to outliers, but some of them are not. So you need to know when the outliers, you need to remove them and when you don't need it to, right? So yeah, here's the outlier. And the next thing we will look at is permutation and random sampling. So for that part, what we will look at is, okay, I just, here is a thing that I didn't talk about is this. So this statement produces 1 and -1 values based on whether the value in data are positive or negative. Then the next thing is permutation and random sampling. So permutation, a series or the rows in a data frame is easy to do. Use the NumPy random permutation function. Calling permutation with the length of the axis you want to permute produces an array of integers indicating the new ordering. So, okay, what we are looking at is like this. DF data frame, we get this. So yeah, we have this data frame, right? And have this data frame and we do the permutation, simpler permutation. And then we will assign this sampler to, okay. So it actually this sampler array used in iloc-based indexing or equivalent take function. So this take function actually is kind of same like you use iloc. So to select a random subset without replacement, we can use sample method on series and data frame. So for example, okay, then we get 3 sample. So permutation and random sampling is very common when you want to do some ensemble learning. For example, random forest. Every time you may need to extract some sample records and to train your data. So that is, so train your like algorithm. So yeah, so that's how we do the permutation take sample. And then another thing we need to look at is that, so we want to generate a sample with a replacement, that we can pass a replacement is equal to true. So let's check the next part, which is computing indicator and dummy variables. So dummy variables, if a column has k distinct values, we want to derive a matrix or data frame with the k columns contain all ones and zeros. Pandas has get dummy functions for doing this. No, devising one yourself is not difficult. So we can use get dummies, right? We can use get dummies, which is important because we have, okay, see, so we change. Okay, let's check what's in the beginning. Okay, it's like this. And right now we get dummies. And so in some cases, we want to add a prefix to the columns in the indicator. So we will use get dummies and add an argument, which is prefix. So this is how we get the predicts. Then we have something new here, right? See, we have this prefix. And the next part for us is df with dummies, which we need to join back. Dummies, join dummies. Okay, dummies, it's like this. So right now, let's see what happened to our, see, we have data one, but we also have more dummy variables here. And if a row in data frame belongs to multiple categories, things are a bit more complicated. So let's check if we have 1 million data set, and let's check this. Okay. So we have movies. So how many movie values are there? Movies dot shape. Okay, this is only part of the table, or part of this table. So we have many rounders, right? Oh, wow, a lot of them. So first, what we do is create a blank list, and then we separated, split all of these rounders, and then we can see these are the rounders that we want. So yeah, this is actually the most important part is this, how to use x dot split, right? To separate these rounders, and then we use unique to only get the set of these rounders. Actually, the most important or difficult part for this is to create the dummy variables like rounders, animation, and any movie that has the rounders, animation should be 1, right? So you can imagine there will be many columns here like rounders, animation rounders, children, and the rounders comedy. And then for Toy Story, everything here, the value in this dummy variable will all be 1, right? So that is how we do this. And let's go to next. One way to construct the indicator data frame is to start with a data frame of all zeros. So here we have all zeros, right? Okay, zero matrix and dummy, okay, columns is equal to rounders. So this is a blank dummy variable. And then we have, okay, for movies rounders, the first one, So this is what's in there. This is for the Toy Story. See here, Toy Story's rounder, and we can do split. We can split it. And so let's see what is the split result and get indexer. So this is dummies get indexer. Okay. So the get indexer actually is to, then we use ilog to set values based on these indices. See? So right now in our dummies, we have all of the things that we want. So it's very, I think it's a skill, or it's, we need to remember, because next time when we face with this kind of thing, this kind of, I mean, a long string that has a lot of maybe categories that you want to extract out, and finally you need to fill in a 1 and a 0 in this matrix, then you can use this, which is easy for you to follow. Okay, so this is a result, and so a useful thing for statistical application is to combine get dummies with a discretion, with a like a cut. So to create bins. So for example, this one, okay, we get dummies based on the bins, which I think is also a very good thing, a great thing for you to follow, because in data analysis, if you don't, after we do the bins, for example, create some bins for age, and then we will turn it into dummy variables. But for this, we can just do it in one step, two things in one step. So why not, right? So let's go to the string manipulation part. So in many string applications, built-in string method are sufficient. For example, split. So we split this by comma, and we can also save the result, yeah, by use this. And these substrings could be merged together with two colon delimiter using addition. So first, second, third, they are all pieces. Let's see the result, which is join pieces. Okay. But this isn't a practical generic method. A faster and more Pythonic way is to pass this a tuple to the join method on the string two column. So these two are the same, actually. For example, I want comma. So this is the result, and then what we can do is locate substrings using Python's in keyword is best way to detect a substring. The index and find can also be used. So yeah, we can know if it is true or not, and we can find, okay. So what's in VAL? This is VAL, and the index for comma. And we want to find the colon. Okay, but there is no colon. Okay. How can we find that? Which is weird. So the difference between find and index is that index raises an exception if string is not found. And the count returns the number of occurrence of a particular substring. So we can also do replace, and it's commonly used to delete patterns, for example, by passing an empty string. So there are lots of things that we can use for string, like ends with, starts with, join, index, find, a lot of things that we can use. And the next part, we will look at regular expressions. So regular expressions really provides a flexible way to search or match string patterns. In text, a single expression called regex is a string formed according to the regular expression language. So the RE module functions fall into three categories: pattern matching, substitution, and splitting. So actually when we use it, we always use it for like natural language processing. But actually in NLP, there are there is a whole like process. So maybe sometimes we don't need to use regular expressions anymore. But let's see what we can get. Okay. What we can get here. And when we call RE split space, a regular expression is first compiled and then split method is called on the past text. So we can compile in the regex ourselves with a re compile, and then we can do the split. So split is to do compile together and then split, but we can also do compile first and then split. The next thing is if we want to get a list of all patterns matching the regex, we can use the find all method. The next thing is that we create a regex object with RE compile. It's highly recommended if you intended to apply the same expression to many strings. It can save you CPU cycles. So match and search are closely related to find all, while find all returns all matches in a string. Search returns only the first match, and match only matches at the beginning of the string. As a less trivial example, let's consider a block of text and of this email address, and we have a pattern, and we compile it, and we want to find the text. Find all text, and so search returns a special match object for the first email address in the text. For the preceding regex, the match object can only tell us the start and end position of the pattern in the string. So let's run it and to see what happened here. Okay, for M is look like this, and this one is look like this. So regex match returns now as none, as it only will match if a pattern occurs at the start of the string. So it's none. Sub will return a new string with the occurrence of the pattern replaced by a new string. So if we want to find email address and segment each address into its three components: username, domain name, and domain suffix. To do this, put parentheses around the parts of the pattern to segment. Okay. And a match object produced by this modified regex returns a tuple of pattern components with its groups method. And the find all returns a list of tuples when patterns has groups, and the sub also has access to groups in each match using special symbols like, yeah, like these three. And so let's check the result. So the next thing I will look at is vectorized string functions in pandas. So this is data, what's in data. Let's look at, okay, it's name and the email, and the string contains email, yeah, string find all, okay. So this is to do the vectorized element retrieval. You should use get or index to string attribute. And so the extract method will return the captured groups of a regular expression as a data frame. So do we have extract here? No, we don't have extract. So let me check. Okay, after find all, we have here matches, right? After find, okay, so matches is equal to find all string dot string, okay, dot string 0. So this is matches. And then we have matches. Okay, so this is the right matches. And the next part for us is to, okay, we have string 5, and we have data string dot dot extract and pattern comma flags is equal to re dot gnorece. So this is a result of extract, return the captured groups of a regular expression as a data frame. Okay, so that's all about chapter 7. And I think the most important thing, actually there are a lot of things are very important, and just in this book, it just talks some like basic knowledge. So for example, I think the very important thing here is, okay, how can we do, how can we feel missing or missing value, and what way should we choose, like forward, fill, or fill with a mean. So how to decide. And another thing is very important is for outlier. So how to identify outlier, and how to remove outlier, and in different algorithm, which method you will choose. Do you need to always remove outliers? And also maybe outlier means opportunities. So how can you identify that opportunities? And also a very important thing is, okay, for you, how to create dummy variables. Sometimes category is very complicated. Maybe in this, in the column of categorical variables, there are there are multiple like categories. They are combined together and put them in just one column. So what we'll do, and here it tells us a very good way to do it, right? So in this like movie example. And another very important thing is, how to deal with a string. So right now we have an NLP package. We can do a lot of things. We can create like word matrix, but we still need to know some basic way how to deal with the string variables, especially for email, because for a customer, they may have several emails and maybe some of them are the same, but just someone or the system or the customer input some wrong email. I mean, it's very important for you to know how to deal with a string, right? Because there will be typo, and then we need to find out the part that we would like to find. For example, we want the username, then we want the domain name, we want domain suffix to separate them, how to separate them. So so I think for chapter 7, that's all I want to talk about. And then I will stop here. So see you tomorrow.